So reference angles. Reference angles can help us to find the trig values of other angles. That doesn't sound too exciting probably, but actually it's pretty interesting. Reference angles are the acute angles. Gotta be acute. Always acute angles. And they're formed between the terminal ray of the original angle that we're looking for and the x-axis. So they have to be acute, they have to be grounded by the x-axis. And the amazing thing is that the trig values of the original function, of the original angle, will be numerically identical to those of the reference angle. I say numerically, it's kind of like the absolute value. Sorry I don't write faster. So if we can find out the trig values for the reference angle, we've got the trig values for the original angle. So the reference angle has a sine value of square root of 3 over 2. So does the original angle. There's just one little thing we've got to worry about, whether this value is positive or negative. Whether these values depends upon the location of the terminal ray. What quadrant are we in? It's all location. So we'll have to actually draw the pictures, see where the angles are coming out. Maybe it'll make more sense when we try some. So let's give them a try. So we're asked to find the sine of 170 in terms of a reference angle. So first thing we're going to do is draw the 170 degrees in the circle. Not going to draw big fancy circles here. So 170 degrees, that should be just shy of 180 here. Now the reference angle is going to have to be between that terminal ray and the x-axis. And it's got to be acute, so it can't be all of this. The reference angle is right here. That's the reference angle. So the reference angle is going to be the measure of the reference angle. Sorry, I forgot I'm writing in cursive. It's going to have to be 10 degrees. This is 170. This is the x-axis. This has got to be 10 degrees. So the sine of 170 degrees is going to equal whatever the sine of 10 degrees is. But we have to ask ourselves, is this positive or is it negative? Well, in this location right here, remember the sine values are the y values. It's up above the origin, so the sine value would be positive. The y value here would be a positive y value. So the sine of 70 is going to be exactly the same as the sine of 10 degrees. It would be positive in this case. Maybe another one. Same deal in terms of a reference angle. The sine of negative 15 degrees. All right, so we'll draw our circle. A little bit bigger this time. Negative 15 degrees is going to be down this way. Negative 15. All right. Now the reference angle is going to be formed between the positive x-axis and the terminal ray. This is the reference angle. Now they always take reference angles to be positive. So the reference angle is positive 15 degrees. If we know the sine value for 15 degrees, we know the sine value for negative 15 degrees. We would just have to decide, is it going to be a positive answer or a negative answer? So the sine of negative 15 is going to equal either sine of positive 15 or the opposite of the sine of 15. Depends on the location, but we know that the sine value for negative 15 is the same as the sine value for the reference angle, whatever number that is. According to this location, the y value is down below center, down below the origin, so the sine of negative 15 degrees in this case will be the opposite of the sine of 15 degrees. It will be the opposite of the sine on a reference angle. That was a strange little problem. The sine of excuse me, please. The sine of 200 degrees. So, got ourselves another circle, and I know this is tedious, but it will help us come up with our final result. Initial ray, coming around 90, 180, 200 might be here somewhere. Okay, so our reference angle is going to be between this terminal ray and the x-axis. Well, we could go this way, but our reference angle has to be acute. So we're going to have to use this part of the x-axis. And this angle right here is going to be our reference angle. Well, if this is 200, and we know that this is 180, then our reference angle right here has got to be 20 degrees. So the sine value for 200 is going to either equal the sine of 20 degrees, or it's going to equal the opposite of the sine of 20 degrees, depending on location. Is the sine value for this angle going to be a positive, or is it going to be a negative? Well, we are down here below center, down below the origin. So in this case, the sine of 200 is going to equal the opposite of the sine of 20 degrees. We could also tell about the cosine. Cosine of 200 is going to be the same as the cosine of 20, positive or negative. Down below center here, it would be negative. It's going to be the opposite of the cosine of 20. But the tangent. Well, the tangent of 200 is going to be the same numerically as the tangent of 20. We'd have to decide in this quadrant, is the tangent value positive or is it negative? Well, tangent is sine divided by cosine. If the sine's going to be negative and the cosine's going to be negative, the tangent would be positive. So it's pulling together a lot of the stuff we already know. I have to be honest. Once calculators became so widely accessible, reference angles for angles like this fell out of favor. I mean, these were wonderful when what you had was just a list of tables. So if you're trying to find the sine value for 200 degrees, they didn't bring the tables all the way up through 200 degrees. They only brought them up to 90, sometimes only to 45. And if you could just use the sine value for 20 degrees, you didn't need a table that went all the way up to 200 degrees. Sine of 20 degrees would do it. You just had to know from the location whether it's going to be a positive answer or a negative answer. Let's try one more of these. That paper's got spots on it. So if we have the sine of 330 degrees. Draw our circle. (330 degrees). So we're coming around 90, 180, 270. 330 is a long ways around there. So our reference angle is going to be between this terminal ray and the x-axis. Well, this is 330. Our reference angle here is going to have to be what's left out of the circle. So the reference angle is going to equal 30 degrees. And the sine of 330 is going to have to be the same as the sine of it's going to be positive sine of 30 Or maybe negative sine of 30. Sorry, kind of ran off the page there. But we know the sine of 30 degrees. This is one for which we don't need a calculator, because we can count on our fingers. If this is 0, then 30 degrees is here. Sine value is going to be the square root of 1 divided by 2. So it's going to either be positive 1/2, or it's going to have to be negative 1/2. At this location right here, the sine value is going to be negative. So the sine of 330 degrees, which is the same as the sine of 30 degrees but negative. And while we're at it, we could also find the cosine of 330 degrees. It's going to be the same as the cosine of the reference angle. Okay, if you don't have them memorized, you can use your fingers. Cosine's going to come down from the pinky. Got 3 fingers on this side. So it's either going to equal positive square root of 3 divided by 2, or it's going to equal the opposite of the square root of 3 divided by 2. Which one shall it be? Well, in this location, cosine, remember, are the x's. We're over to the right of the origin, so the x's, the cosines, are positive. In this case, it's going that the cosine of 330 degrees is going to be the positive square root of 3 over 2. So we're going to be putting together what we already have learned, I hope. So I hope you're able to print out the sheet that says class exercises, special trig values, reference angles. And it also says sketch the angle in a circle for each problem. I'm going to try a few of these. We actually have already done most of number 4. And using a calculator for these is not really helpful for reference angles. Sine and cosine values on number 10. So let's give number 10A a try. Okay, sine of 45 degrees is its own reference angle. 45 degrees right here, that is the acute angle in between. Now, sine of 45 degrees, we're supposed to already know that's one of these fingerful ones. So 45 degrees is right in the middle. Sine of 45 is square root of 2 divided by 2. For part B, 135 degrees. Well, we got 90, 180, so 135 is going to be right here. And our reference angle is going to be between this terminal ray and the x-axis, which makes our reference angle 45 degrees. So our reference angle's sine value was square root of 2 over 2. That means the sine of 135 has got to be square root of 2 over 2. We just have to decide in this location right here, this terminal ray, is the sine value positive or negative? It's up above the origin, so the sine value for 135 is going to have to equal positive square root of 2 over 2. I'm just going to skip to D because I'm running out of space to draw my circles. Sine of 315. I'm going to put the 315 here in a circle, sort of. My 315 degrees were past 90, past 180, past 270. 315 degrees goes a long ways around. It's almost a 360, but not quite. 315 would have to be 45 more than 270. Or you could say 315 is 45 degrees less than 360. So our reference angle is 45 degrees. You might have guessed that since they started with a 45. The sine value for 315 is going to equal the square root of 2 over 2, because that's the sine value for the reference angle. In this location, would it be a positive or negative value? Well, we are coming out of the circle down below center. This would have to be a negative square root of 2 over 2. A number 12. Number 12, we don't need a circle for every single one because they're giving us 30 degrees for part A and 30 degrees for part C. Negative 30 degrees for part B, yeah, we don't need. So one circle is going to take care of both A and C. Supposed to draw a 30-degree angle. And the sine value of 30 degrees, it is its own reference angle right there. So the sine value for 30 degrees is going to be the square root of 1 divided by 2. So the sine value for 30 degrees is 1/2. One of the easiest ones for most people to remember. For part C, the cosine of 30 degrees is going to be coming from the pinky on down, the square root of 3 divided by 2. And it's in the first quadrant. Everybody's positive in the first quadrant. For parts B and D, they want us to draw an angle measuring negative 30 degrees. Well, the reference angle for that is going to be 30 degrees. So our reference angle is going to measure 30 degrees because that's what's between the terminal ray and the x-axis. We already know the sine and cosine values. For part B, they want to know the sine of negative 30. Well, it's going to be the same as the sine of 30. Sine of 30 is 1/2. We'll just have to decide in this location, is the sine value positive or negative? It's down below center, so it would be negative 1/2. Negative sign isn't tracking too well here. Okay, the cosine of negative 30 is going to have to be the same as the cosine of positive 30. We'll just have to decide at that location, Is it a positive value or a negative value? Cosines are the x's. We are over to the right of the origin, so the cosine of negative 30 is going to be a positive square root of 3 over 2. We've been sort of messing with degrees because that's the easiest for most people. But number 14. They want the cosine of pi over 4. Well, pi over 2 is up here. So pi over 4 is going to have to be coming right out through here. It is in the first quadrant. It's its own reference angle. The cosine of pi over 4 is going to be whatever the cosine of pi over 4 is. Pi over 2 is 90 degrees. So pi over 4 is 45 degrees. The cosine of pi over 4 is going to have to equal the cosine of 45, which we're getting to learn by now that the cosine and sines of 45 are both the same. They're both the square root of 2 divided by 2. For part B on number 14, the sine of negative pi over 3 so that would be pi over 2's down, negative pi over 2's down here, so negative pi over 3 might be about here. Now, if you don't have them memorized for the radian values, we're going to have to change this pi over 3 into degrees. If you know that pi represents 180 degrees, then pi divided by 3 is going to be equivalent to negative 60 degrees. Which means the sine value for 60 degrees is we're going to use 60 degrees as our reference angle. Because that's between the terminal ray and the x-axis, and it's acute. So the sine of 60 degrees is here. Sine value is coming up this way. The sine of 60 degrees is the square root of 3 divided by 2. At this point, is the sine value going to be a positive or negative? We are down below the origin, so the sine of negative pi over 3 is going to be the opposite of the square root of 3 divided by 2. If you would please do the U-try, which asks you to do numbers 5, 11, and 13 from this very same sheet. Thank you.